Yes. In which question?
Question one, part six.
Okay. Question one, part six. Okay, let me write this. So question one, sixth part is 3i and then bracket 7 minus 4i, and we have to write this in form of x plus iy. So firstly, we will multiply this 3i inside the bracket. So it will be 21i and 3 into 4, that is 12i square. So we know that the I square is equals to -1. So I'm replacing I square by -1. So that will be 21i plus 12, or I can write this as 12 plus I21 or 21i. So now it is written in the form of x plus iy. Sorry.
Okay, thank you.
Yes. Any other doubt, Mahima?
No, that's it. Thank you.
Okay. So have you solved any part of the second question?
No, I haven't.
Okay. Okay, just solve one part. I think z square minus 2z plus 5 is equals to 7. Please try to solve this.
I'm getting 1 plus or minus 2i.
Okay, let's see. So here value of A is 1, B is negative 2, and C is 5. So the formula will be minus B plus minus the square root of B square minus 4AC over 2A. So B is negative 2 and there is already a negative sign, so that will make it positive 2 plus minus B square. Square of negative 2 will be positive 4 minus 4 into A, that is 1. So 4 into 1, that is 4 into C. C is 5, so that will be minus 20 over 2A. A is 1, so 2 into 1, that is 2. So is equals to 2 plus minus, that will be negative 16 over 2. And I can write negative 16 as 2 plus minus 16 I square, because value of I square is negative 1. So taking this 16 and I square outside of the square root. So 4 is the 16 is the square of 4. So 4I over 2, or I can take 2 as common from the numerator. So that will be 1 plus minus 2I over 2. So this 2 will be cancelled out. So final answer will be 1 plus 2I, and the other root will be 1 minus 2I. Have you got the same values?
Yes.
Okay. Let's move to the new topic of complex numbers. Modulus and conjugate of a complex. So let's say there's a complex number which is in the form of A plus IB, means real plus imaginary part. So if we have to find the modulus of any complex number, so that will be A square plus B square, and the square root means the square of the real part plus the square of the number which is written with I. So A square plus B square. And to find the conjugate, there will be just opposite sign of the imaginary parts, like A plus IB. In this, the imaginary part has positive sign, so its conjugate will be having the negative sign. So let's write. I'm writing some examples also. Yes. Example number 1. Let's say 3 plus I. This is a complex number, and we have to find the modulus. So its modulus will be square root of the square of the real part is 3. So 3 square plus, here the number which is written with I is 1. So it's a square. 1 is square. So 3 square is 9, and plus 1 square is 1. So that will be root 10. And if I have to find the conjugate, so conjugate z bar, or in some book it is also written as z, and a star is placed over there. So its conjugate will be, you have to just do the opposite sign of the imaginary part. Here the imaginary part is of positive, so it will become negative. So that is 3 minus I. So I'm writing one complex, another complex number, and you have to find the modulus and the conjugate of that. Any problem in this one, Fahima?
No problem. Thank you.
Oh, okay. So let's say Z is minus 3i minus 5. Please find the modulus and conjugate.
I'm getting my modulus as root 34.
Okay.
And my conjugate is 3i plus 5.
So okay, the modulus part is correct, but there's a slight mistake in the conjugate part. As I told you that you have to change the sign of the imaginary part, but you have changed the sign of the real part also in this one. So real part remain as it is. That is, the correct will be 3i minus 5. Real part will remain as it is. You have to change the sign of the imaginary part only.
Okay.
Yes.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
To find the multiplicative inverse of any complex number, okay, so to find the multiplicative inverse of any complex number, we just calculated the conjugate and the modulus. So its formula will be for the multiplicative inverse. In numerator, you have to write the conjugate and you have to divide the numerator by the modulus of that complex number. Then there are some other properties which are very common, that if two complex number are in product and we have to find the modulus of them, so that will be equal to the modulus of the first complex number multiplied by the modulus of the second complex number, similar in the division process. Means you can write them in parts as well. There is no issue. So the main thing is this one, the multiplicative inverse. It is conjugate of that complex number divided by the modulus of the complex, sorry, square of the modulus of the complex number. And so I'm giving a question to you. Just the question is that you have to find multiplicative inverse. You have to find the multiplicative inverse of 2 minus 3i. So please try solving this one. You have to find the multiplicative inverse of 2 minus 3i.
Is it 2 plus 3i over 13?
Yes, it will be 2 plus 3i over 13. It's correct. Okay. So we covered some basics, the question based on the complex number, in which you have to express a complex number in the form of a plus ib. So there was only a simple expression, but let's say if the expression is in like numerator over denominator, 5 plus root 2i, 1 minus root 2i, and you have to express this in a plus ib form. And there is second part as well. So let me write this. It is, yes, this is the first part. And the second part is I raised to the power negative 35. And you have to express this as well in the form of a plus ib. So, Fahima, how will you solve the first part?
Mm. Give me a second. I'm not very sure how to divide them.
Okay, so do you know the concept of rationalization?
Yes.
Yes, so you have to do rationalization because there is a root present in the denominator. So the first step will be you have to do the rationalization. That will be it. Then you will be able to get the formula.
Is part A 21 plus 72i?
Okay, I don't think it's correct. 21 plus 72i. Okay, we'll see. And okay, let's discuss the first part. So when we do the rationalization, so numerator is at 5 plus root 2i over 1 minus root 2i. So we will multiply by its conjugate. Conjugate means you have to change the sign of the imaginary part only. That will become 1 plus root 2i and 1 plus root 2i. So solving the numerator, so 5 into 1, that will be 5. 5 into root 2i, so that will be 5 root 2i. Then root 2i will be multiplied by I, so that is root 2i. Yes. So root 2i into root 2i, so that will be plus root 2 into root 2, that will become 2, and I into I, so that will be I square. And in denominator, you can see that it is written in the form of a minus b and a plus b, which is equals to a square minus b square. Mean the square of the first term, here the first term is 1. So its square will be 1 minus the square of the second term. That is root 2i. If I do the square of root 2, that will be 2. And if I do the square root of I, that will be, sorry, if I do the square of I, that will be I square. So now solving this one. So 5 root 2i and one more root 2i is added to it. So that will become 5 plus 6 root 2i. And value of I square is negative 1. So when you multiply negative 1 by 2, so you will get negative 2, 1. And the value of I square is negative 1. So when negative 1 is multiplied by negative 2, so this will become positive 2. So 5 minus 2, that will be 3, plus 6 root 2i over 3. So I can take 3 as common in the from the numerator. So that will be 1 plus root 2i, 3, 1 plus 2 root 2i over 3. So this will be cancelled out, and our final answer will be 1 plus 2 root 2i. It is written now in form of a plus ib. So please go through this once, and if you have any doubt in any of the steps, do let me.
It's clear.
Okay, now try the second part. You have to write this in form of a plus ip, I raised to the power negative 35.
Is this the multiplicative inverse of a?
Sorry, can you please repeat what you have said?
I'm asking if this is the multiplicative inverse of a complex number, or is it like how we solved yesterday?
Yes, you have to solve this like this. So in such type of question, firstly try to make this exponent as positive. Here it is negative. So how can we make any exponent negative? Sorry, positive. So we have to do reciprocal for that. So 1 over I raised to the power 35. So if you want to change the sign of the power, so just do reciprocal of that. So now it is 1 over I raised to the power 35, or I can write this as 1 over I square raised to the power 17. So that will be I raised to the power 34, and one more I is required, so multiplied by I, because we know the value of I square. So that is why I have written I square in the bracket. So that will be, if I substitute the value of I square, so that will be negative 1 raised to the power 17 into I. So there's a negative term and its power is odd. So it will be negative. That is, it will be 1 over minus I, or you can write this as, yes, that's the correct one, 1 minus I. Or if you want, if we have to express this in form of a plus ib. Yes, a plus ib. So there is no real part. So for real part, you have to write 0 minus 1 over I into b.
I'm done.
Okay, so here we have 1 over negative I, or minus 1 over I. So if I have to like I have to write I in the numerator. So how can I write this I in the numerator?
I to the power of negative I to the power of -1.
So you are saying that it will be negative I raised to the power -1.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Right?
Or yeah,
Yes. So, or what we can do, we can multiply by I on the numerator and denominator, because in the denominator, this will become I into I, that is I square, its value will be -1, and there is already a negative sign, so it will be I. So here you have okay. So this method is used, which I just told you, that whenever we want to change the sign of the exponent, then we just do the reciprocal of it. But here we don't want to change the sign of the exponent. We want to change the denominator. We want something in the numerator and want to remove something from the denominator. So that is why I have multiplied this by I.
Okay.
This is also correct. This is not incorrect, which you have done. It is also correct, but this is preferable when you have to change the sign of the exponent. Okay, have you written this? Okay.
Yes.
So the next question is 3 plus I root 5 multiplied by 3 minus I root 5 over root 3 plus root 2I minus root 3 minus I root 2. And you have to write this in form of A plus I. Have you got the answer? 5 now.
I'm
Are you
not sure if I'm right.
okay? Let me stop. Okay, so I am solving numerator and denominator separately so that there is no confusion. Firstly, I'm solving numerator. So you can see that the numerator is written in form of A plus B, A minus B. And so that algebraic identity is equals to the square of the first term. That is A square minus B square minus a square of the second term. So here the first term is 3, its square will be 9 minus a square of the second term. So square of root 5 will be 5 and I square will be I square. So if I substitute the value of I square, that is -1, so this will become 9 plus 5, that is 14. Now I'm solving the denominator. So firstly I'm removing the bracket. So this negative sign will be multiplied inside the bracket. So this will become negative root 3 and minus minus plus root 2I. So this positive root 3 and the negative root 3 will be cancelled out. Root 2I plus root 2I, that will be 2 root 2I. So the numerator is 14. Denominator is 2 root 2I, or it is cancelled. So 7 over root 2I. I want to eliminate this root and I from the denominator. So I will be multiplying by root 2I in numerator and denominator both. So 7 into root 2I, that will be 7 root 2I, and root 2 into root 2, that is 2, and I into I, that is I square, and the value of I square is -1. So it will be minus 7 over root 2 over 2i. And if I have to write this in a plus ib form, so we don't have any real part over here. So that will be 0 plus, and the imaginary part is this. So please go through this once, and if you have any doubt, do let me.
Done.
Okay, any doubt in this one?
No, thank you.
Okay. So I will, yes, I will share another set of questions with you. I'll try solving that one then. Yes, I will share um, 6 more questions with you.